All right, grade 7. So this week we're going to be moving on to potential and kinetic energy in systems. All right, and we're going to focus on four main systems. The four systems being mechanical systems, thermal systems, electrical systems, and biological systems. All right, so last week you learned about the difference between potential and kinetic energy. We know that potential energy is stored energy, and it can be stored in a number of ways. So either in the form of fuel, in the case of, say, gas or petrol, candle wax, and food. And then you would have learned that food's also measured in joules, so that'll tell you, or kilojoules, that'll tell you how much energy is in the food that you eat. All right, and then we know that kinetic energy is moving energy. So what this week focuses on is just making sure that you're able to identify where and when does that change take place from potential energy into kinetic energy through the four different systems. All right, so it's pretty straightforward and basics, and as soon as you have it down, you'll have no problem moving forward with this unit. Okay, so firstly, if you look at the energy transfer in a mechanical system, so we first play this little clip and we see this guy busy riding the bike, all right, and then he crashes into bike animation. But we can break this down. Okay, so basically a mechanical system has moving parts, for example, the bicycle, which has energy that can be transferred to different parts of the system. Your body stores potential energy, and when you push the pedals of the bicycle, the potential energy from your body is changed into kinetic energy in your legs. Right, the kinetic energy from your leg muscles is transferred to the bicycle, which makes the bicycle move. Okay, we can show this in the form of an energy or flow diagram. So on page number 106 in your textbook, I want you to focus on that flow diagram, because in a test, this is what I would ask you to draw. So I wouldn't ask you to draw the whole bicycle with the person pedaling and then give me a breakdown. I would just ask you to draw a flow diagram. And then in the flow diagram, it's important to note that each thing will say, so potential energy in the leg muscles, the first one, then it mentions kinetic energy. So now the food that man has eaten in the morning, okay, has now been transferred into kinetic energy in his legs in order for him to transfer that kinetic energy to the kinetic energy in the pedals, and then again a moving energy into the wheels, so the wheels start to turn, and then the bicycle moves forward. So there's your breakdown from potential energy all the way to kinetic energy. So for practical activity 1, it's looking at or asking you to take a ruler with an eraser, all right, or to roll up a ball of paper, and then you have to flick this paper off the ruler. So now you have to think, where is the potential energy stored and when is it converted into kinetic energy once the piece of paper gets flung forward. All right, you're going to do this practical activity and then you have to break that down for me. And each one you will have to draw a flow diagram to observe or to record your results. Okay, so that's a mechanical system. The next one being energy transfer in a thermal system. So when we talk about thermal system, we're talking about heat. And then later on in the term, you're going to learn about 3 different types of heat transfer, mainly through conduction, convection, and radiation. Okay, but for now, we're just looking at the energy transfer in a thermal system. So how is the energy transferred from a heating source into the water? So for the practical activity, it looks at using a candle and a box of matches, a tin can, 200 ml of water, tongs, and an oven glove. We're going to look at rather a system of a pot of boiling water on a stove. Well, in this case, it's not boiling yet. It's just a pot of water on the stove. And we have to identify now, what is our source of energy? Okay, so our source of energy will be electrical energy in this case, because I'm not using a candle in this example. But when you answer the questions for practical activity 2, think of what type of energy is a candle, right? And think back to the previous exercise that you've done. But in this case, the stove gets switched on and then there's a transfer that happens. All right, so the electrical energy is stored potential energy. As soon as he switches it on, it gets transferred. So the heat heats up the pot and then that gets transferred into the water. All right, and then we're seeing a conversion take place. So we're seeing the potential energy that was stored in the form of electrical energy get transferred and become kinetic energy. As soon as the water starts boiling, we know that now is kinetic energy in the water as well as the water starts to move. But even before that, the heat that's being conducted through is kinetic energy. All right, so identifying where that transfer takes place. So in the case of practical activity 2, on page 107, just think of the candle. What is that? Is it stored energy in the form of what? And then when does that energy get transferred into kinetic energy? As soon as the water boils, or is it before the water boils? Okay, the next system. All right, so the next system being a electrical system. So if we go to the flow of electricity, all right, if we look at this is a circuit diagram, which you would have learned about last year, but we're looking at now what is the stored energy and when does it become kinetic energy. So we know in this case that the battery is stored chemical energy, all right, and this is a form of potential energy. And you've learned about atoms. So with regards to the atoms, you have electrons that flow through your circuit. All right, and that lights up the light bulb. So if you play this over here, we'll see now that we see movement taking place. So it's notifying where does the conversion take place. So we know that it was potential energy being converted into kinetic energy as it goes through the resistor and then returns back to the battery. All right, so that's a form of an electrical system. Again, you'll be able to identify when the conversion takes place between potential and kinetic energy. Lastly is your biological systems, and this is pretty straightforward and basic. You've learned about food chains. What I want you to do is to please add on page number 109, you'll see that the energy transfer in a food chain, they give you a food chain starting with a cabbage, a snail, a guinea fowl, and jackal. Just please to put the sun first. So the energy always comes from the sun. We know that the cabbage through photosynthesis would have converted the sun's energy into food, right? And that food gets transferred to the snail, then to the guinea fowl, then to the jackal. Now, again, it's potential energy in the cabbage. The snail then converts it to kinetic energy, but the snail itself still stores energy, which is potential energy. And then the guinea fowl would eat the snail, jackal would eat the guinea fowl. Now, remember in the food chain, you would have, last year in the food pyramid, you would have noticed that the bottom of the pyramid had the most energy in it. So each time the energy transfers, it gets less and less and less, because obviously the animal that's eaten the previous animal has used it to obviously do daily activities, all right, but it also still has some of that energy stored in either fat or something along those lines. So that's just the different systems that we're looking at, but the energy transfer is pretty much the same. So it's just identifying when does it go from potential energy to kinetic energy. And the biggest sign to look out for is when does that energy start to move. Although I know in an electrical circuit, we can't physically see the electrons moving through the conducting wire, but you have to picture it in the sense where I gave you this little flow of electricity through the circuit, and then you can identify, okay, the light bulb is shining, so therefore we know that there's kinetic energy taking place because electricity is flowing through the circuit. The same goes for the thermal system. We know that there's kinetic energy happening because the water's starting to boil, so obviously the heat is transferring, and also the water boiling, it's moving, so we know that it is moving energy. In the case of the bicycle or the mechanical system, the same principle. If the person is not moving yet, they are relying on the potential energy in their legs to get the bicycle moving. As soon as the bicycle starts to move, we know that that potential energy has then been converted into kinetic energy. All right, so grade 7, you're going to look at those practical activities for me, and then you're just going to answer the questions that follow. We've broken them down here, and it is pretty straightforward. Just don't get caught out with activity 2. Please note that you're looking at the candle as a form of potential energy and not the stove. All right, so just think about what is that form of energy in the case of a fuel that's being used, and then when does the energy transfer take place. So you'll complete practical activity 1, 2, 3, and 4 over the next 2 NS lessons. Right, and if you have any questions, please feel free to ask. Right, you can email me at any time, and then I'll get back to you as soon as I can.